I mean, functions do appear in many places. The whole fact that you only get one output for each input, that's very important. I mean, what if we had this, what if we had this example? That's not a function. And why is that not a function? Well, 1 is being assigned to 2. 1 is also being assigned to 8. Well, which is the right output, 2 or 8? Well, because of that, this is not a function. I mean, I probably could have drawn more arrows from 2, 3, and 4, but right away we can see we don't have a function. Because again, something from the first set is mapped to more than one element in the second set. I mean, you could make a you could make a function from your calculator. You know, if you take, for instance, the square root key, right? If you press 9, then you press the square root key. 9 is your input. What comes out of the calculator is 3. But what if you had more than one output? What if the calculator gave you more than one value? What if it gave you 3, -3, and 0, let's say? Well, which output are you going to use on a test, right? That's why having only one output is useful. You know what output to use that is. Okay. Are there any questions? Okay. So here we're going to draw a correspondence diagram that's a function. And the whole point is you want one arrow coming out of each domain element. Excuse me. You want one arrow coming out of each element from the domain, from the first set. So this is one example. You know, we saw a few already, right? X and Y are the same actually, right? This is our domain. These are all the things that go into the function. So 1 goes in, the arrow tells us that we get 6 back. 2 goes in, 8 comes back. 3 goes in, 2 goes back. 2 comes out, right? Each input, we get only one output. That's very important. That's extremely important. Okay. It's like so. Okay, so that's what has to happen. What about this one? Well, this is a function, right? Here, you have each input goes to only one output. Each input is going to one output, right? I mean, they all have the same output. That's okay. That can happen. That can happen. There's nothing wrong with that. Okay, so again, they all have the same output. But again, each input, each domain element, right? There's only one arrow coming out of it. That is, each domain element is only assigned one element from Y, from the second set. I mean, they all have the same output, and that's okay. There's nothing wrong with that. Okay. Are there any questions about this one? Remember also, as I said already, with a function, the whole point is you want to define somehow that rule, right? That takes each input from the domain and gives you back an output. You want to somehow specify that rule. Here, we're specifying that rule using a correspondence diagram. using a correspondence diagram. But there's other ways we could specify that rule. We can use relations. So let's consider relations now. Basically, so again, this is what I was just saying. To make a function, right, somehow we have to specify what the rule is between the domain set x and the other set y. That rule has to satisfy the definition, right? For each input, for each element of x, you only get one element from y. So we had correspondence diagrams. Let's consider relations now. So what is a relation? It's just a set of ordered pairs. So a relation, by definition, it's just a set of ordered pairs. Okay, so for instance, this is a relation. 1, 4, 1, 2, 3, 9. Here's another one, -2, 1, 0, 0, and 1, 5. That's another relation. Relation, relation. We have different relations here. Okay? So that's what a relation is. You can probably guess there is going to be there is a relation between a relation, there's a relationship, that's better, between a relation and graphs. Because graphs, you can plot ordered pairs as points, but that'll come later. Relations can also have domains and ranges. The domain of a relation is just a set of all x coordinates, all the first components by definition. So that's what the domain is of a relation. It's all the first components, all the x coordinates, whereas the range is all the second components, that is, it's all the y coordinates. So here, for instance, 1 is also in there. Well, we said 1 already, so we don't say it again. 3, right? That's the domain. Remember, in a set, you don't list something more than once. No repetition. So we have 1, 1's in there already. 3, that's the domain. 4, 2, and 9, the y coordinates, as you can see, that is the range. That is the range. I mean, the idea is that 1 is related to 4, 1 is related to 2. That's what a relation's doing. And 3 is related to 9 in a relation. Here's the same idea. -2, 0, and 1. Okay? That makes up the domain of this relation. Whereas the range is just 1, 0, and 5. That's the relation. Excuse me, that's the range of the relation. And here again, we have -2 is related to 1, 0 is related to 0, 1's related to 5. So we have that kind of relation. All right, good. Okay, now, yes, there's a connection with graphs. That'll come later. There is a connection with correspondence diagrams. I mean, namely because if you have a relation, the first set here, you can make it your domain. The second set, you can make it your range. And for each ordered pair, A, B, what you can do is you can draw an arrow from A to B. Right? You could draw an arrow from A to B. So in other words, from any relation, you can make a correspondence diagram. And you can go the other way around as well. If you have a correspondence diagram, you can make a relation. It's really not hard to see why. At least I hope it's not hard. Basically, if you have A arrow B, you make the ordered pair AB. A comma B, that's better. So there is this connection between relations and correspondence diagrams. Okay, well, let's see some examples. So here we have this relation, right? 1, 3, 2, 4, 4, 6. What's the domain? We have 1, we have 2, and 4. The x coordinates, as you can see. What about the range? The range is 3, 4, and 6. 3, 4, and 6, right? That's what the range is. Three, 4, and 6. Okay, that's good. So let's make the correspondence diagram. So we have 1 arrow, we have 1, 3. So we draw 1 arrow 3, 2 arrow 4, 4 arrow 6. So we have those arrows, right? Again, 1, 3, we have 1 arrow 3, 2, 4, 2 arrow 4, 4, 6, 4 arrow 6. So this is our correspondence diagram, right? So again, from a relation, we can make a correspondence diagram.